Hi folks, we're going to take a look at page 154, number 16. Okay, so I'd referenced this question in the lesson. So here it says if the cost of producing X items is given by the function C of X, so this is our cost function, and then the revenue given by R of X. So again, notice these functions are given in terms of the number of units. All right, then we know that the profit function is just the difference of revenue minus cost. They want us to show that the instantaneous rate of change in profit is zero when marginal revenue equals marginal cost. All right. So let's recall what marginal revenue and marginal cost mean. Okay. So again, marginal revenue, marginal cost are just the derivatives of these functions with respect to the number of units being produced and sold. All right, and I gave a bit of an explanation of that in the lesson. All right, I'm going to go a little backwards. I'm actually take a look. Let's take a look at a graph here. I've got an example here. So R is my revenue function. Okay, now you might sort of think, why does my revenue come down? So by the way, this is with respect to number of units. Well, I guess what probably happens is, given after a certain number of units, probably started increasing the price. And eventually, as you increase the price, less people want to buy it. And so in the end, you might be charging a higher amount, but the revenue decreases because not as many people are buying it. Okay, and then here you got in red the cost function. You notice here that the cost, starts off not at zero, like the revenue. If you don't sell anything, you don't make any money, whereas the cost will have some initial costs, and it looks like it increases more quickly at the beginning and then eventually starts to level off. So it's an example of a reasonable cost function. And so if you want to find your profit, you just take your revenue function and you subtract your cost function. So you can see in this area here, we're losing money because there's negative profit. The costs are higher than your revenue. Same in this area here, but in this interval, our revenue is higher than our cost, hence we're making profit in this interval. All right. Now again, just because I have 1, 2, 3, 4, and 1, 2, don't assume that these are necessarily the number of units. It could be thousands of units. Okay, it could be millions of units. All right. So of course, what we're likely interested in is what's going to give us the maximum profit. Okay, so when you think about it from a geometric sense, you think the difference between these two functions at any one point is just going to be the length between the 2 points. Okay, the distance between the 2 points. So the largest profit will be wherever the distance between the two functions is at the greatest. So it kind of looks like it might be somewhere there. So in fact, if we plot the profit function, okay, we see that, okay, it wasn't too far off. So it looks like it occurs at 4.99, okay, that this distance between the revenue and cost functions is at its maximum. All right. But let's take a look at something interesting here. That what I did is I found the formulas for the slopes of the tangents at that particular point. Okay, so if you did watch the video on point slope form, you'll just notice that that represents the slope of the line, x minus the x value at that point, and then this just represents the y value at that point. Okay, so that's how I did this. I didn't have to calculate anything. Desmos did all the work for me. So let's find the tangent line at 4.99, and let's find the tangent line for cost at 4.99. And I want you to take a look at these two lines. Do you notice something interesting? Okay, well, it looks like the slopes of these tangents are the same. Let's confirm that, because they look like they're parallel, but let's confirm. So here, let's find r prime at 4.99. Okay, and we get 0.816, and then here the derivative of cost at 4.99, and we see we get pretty much the same value. Okay, so it looks as though we're going to have maximum profit when the derivative of the revenue function is equal to the derivative of the cost function. Because remember, the derivative is just the slope of the tangent at that point. Okay? Or if we want to use the more economics type terms, when marginal revenue is equal to marginal cost. Okay, and in fact, if you talk to an accountant or somebody who studied commerce in university, that's probably the one thing they'll remember from their economics course is that you want marginal cost to be equal to marginal revenue. That's what's going to maximize profit. Okay, so this is just sort of a geometric view on this result, but in fact, if you're working with calculus, you can come to this discovery in a much easier way, in a much more algebraic way. Okay, so let's take a look here and see what happens. All right, so we want to show that the instantaneous rate of change of profit, so in other words, the derivative of the profit function, okay, we want to determine where it's equal to 0. Now, of course, you remember that finding where profit is equal to 0 will help us find the optimal values. All right, but when we take the derivative of the profit function, well, hey, remember, profit is just the subtraction of revenue and cost. So that's just going to be the derivative of the revenue function minus the derivative of the cost function, and I want to know when that's equal to 0. And look how easy this is. I realize that that occurs when r prime at x is equal to c prime at x. All right. And so here, what we've shown is that the profit function will have a derivative of 0, or an instantaneous rate of change of 0, when the derivative of the revenue is equal to the derivative of the cost. In other words, when marginal revenue is equal to marginal cost. So here we have marginal revenue equal to marginal cost. All right. And of course, where are you going to find the maximum value for profit? If there is a maximum to be found, you're going to find it where the derivative is 0. So you're going to be looking for where marginal revenue equals marginal cost. Okay, now you can take an economics course and come to this result without using calculus at all. Okay, you can make, there's arguments to be made that show that this will be where you're going to have what's called the equilibrium price. Okay, the price where marginal revenue is equal to marginal cost is going to be the one that you want to charge in order to maximize your profits. Okay, whereas we kind of got to this result by using fairly simple calculus methods. Okay, that's it for this one.